Okay, this is the final video for graphing calculator exercise for analysis 1 where we use the TI-NSpire to solve these problems. I'm going to concentrate on problem 3, which is all about solving equations using graphs. So we're going to solve the equation 5 equals x squared cosine x natural log of x using the intersection function of your calculator with the graphs or the zero function. Just to let you know, my personal preference is to use the zero function. I think it's a little less messy when you use that, but we'll show the intersection function as well. And I actually also want to show you real quickly before we get into this just another store function. Let me do that now, and then we'll get to question 3. I was showing you on the calculator how you could store the coordinates, right? But I just want to show you quickly on a calculator page. You know, right now we have the calculator page. Let's see if I could focus in on there. There we go. I just want you to know that you can store like whatever values. Let me just like type in blah 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 blah, like a big number, whatever number you would get. If you wanted to store it to use in later calculations, if you look above the var, for variable, if you press Control, you'll see STO with an arrow. If you press it without anything in front of it, it'll assume you want to store the answer from whatever you wrote before, or whatever you wrote in there. So let's say I wanted to store this as D. I press D, I press Enter, and now D is represented by that. So if I press D and I press Enter again, you get that. And the thing is, I know some of you have done a thing where you've used the calculator to do like part of a problem and then wrote that answer down to plug into a calculator later, and unfortunately what happens is you get some errors in your calculations because you truncated a kind of a step within the problem. Well, you don't have to do that. If you just store the value in your calculator, then you could just do work with the actual answer or whatever you found halfway through a problem. So this is really important if you want to get accurate answers, storing values. STO is how you could store values into a letter. So in any case, just wanted to show you that. Now, let's get back to what I wanted you to do. I wanted you to solve originally this equation, okay? 5 equals x squared cosine x natural log of x. With the intersection function, we're going to graph f of x, kind of f1 of x equals x squared cosine x natural log of x, f2 of x equals 5, and we're going to find the intersection of those graphs. The x-coordinate would give us our answer. Now, hopefully you guys agree, if I subtract 5 from both sides of this equation, I would end up with 0 equals x squared cosine x natural log x minus 5. Well, if I graph y equals this, right, x squared cosine x natural log of x minus 5, and I find the zeros, well, those would exactly be the x values that make this equal to 0, which would be another way to find the solutions, the way I prefer personally. But let me show you how you could do both of those things with the graph, okay? So we'll start with intersection, okay? So I'm going to, remember I did this in the last video, I want to go back to the graph page. So if I hold Control, actually if I just click Control, then click left, that gets me back to this graph page. And if I scroll, okay, I'm actually going to have to, if you go to Menu, and if you go to, we want to go to Graph Entry and go to Function. If I click there, you could see that F2 of X things comes up, and you can see my cursor's in there. Now if I move up, you could see F1 of X is stored there, x squared cosine x natural log of X, and down here we have F2 of X, and for our case I'm going to make it 5, okay? So now if I press Enter, you'll see that graph show up, okay? And you could kind of see it clear enough. If you needed to zoom in, we talked about how you could do zoom box if you wanted to see exactly where it's intersecting, but between the numbers 1 and 8, you could see there's 2 different places where these 2 graphs intersect. So what you would do now is you would go to Use Menu, we go back to this Analyze Graph option, and if I go to Intersection, you could find the intersections kind of the same exact way you did zeros, minimums, and maximums. Look, lower bound, I'm going to try to find this intersection for now, and you would find the second intersection the same way. So lower bound, I just go to the left of the intersection I'm looking at, press enter. Upper bound, I go to the right, press enter, and you could see right away that you get 4.85 is the x-coordinate. Now the 5 is the y-coordinate. That's just pretty much saying, like, you know, what the value of the left side and the right side of the equation would become, which depending on the problem can be useful, but you know, really what's useful to us is these x-coordinates. That's the x value that satisfies the equation. Okay. Now you could see I only see 4.85. If I wanted something like 3 decimal places or 4 decimal places, you could do what I did in the previous video. Store that value, go to the calculator page, press enter, and then you would see all the other decimal places that are associated with it. Okay. So that's one way you could pull this off. The other way, so let me I'm going to drag, once again, just click on this. I'm just going to drag it out of the way for now, and you know, you could click on it and delete it, but let me just get it out of the way for now. Worst comes to worst, if your graph gets all cluttered and you don't know how to get rid of stuff, you just delete the graph page, start a new graph page. It's not the end of the world. So now I want to show the other way, right? So I'm going to, let me go back to menu, go to graph entry exit, go to function. It'll bring me back to these bottom things. Now the f of 2, I just pressed up to go to f of 2. I'm going to delete that and press, leave that as an equals. I'm just going to press enter with nothing there, so that should get rid of that graph, which is great. Let me go back to menu, graph entry, function, and now I'm going to go to function 1, and I'm going to put -5, okay, -5. And now I'm going to press enter. And that should just translate the graph down 5 units, which is exactly what happened. Because the y scale is so large, you didn't even notice, it didn't look like anything happened, but trust me, the whole graph went down 5 units. So now, the zeros of this graph would represent the solution to this equation. So if I go to menu, then I go to analyze graph, then I go to 0, right? Then I could lower bound, I'm trying to move it. Okay, there we go. Lower bound, go to the left of this 0. I'm just going to go to the first 0 so you can see you get the same exact x-coordinate. Then I go to the right of the 0 and I press enter. And look, once again, you get that same exact 0 here, 4.85. You could do the same thing for this 0 over here. There's actually 2 solutions in this case for the problem I asked. I'll leave that for you to figure out. But same deal, you know, if I wanted to see this in more decimal points, I could double click. I could press Control, Menu, Store. I'll store it as F. Why not? Press Enter. Okay, and I'll press Control and click right so that I could go to the calculator page. And now, if I press F and Enter, you could actually get all of the decimal places for that. You know, for that function, which is pretty neat. So there you have it. That's how you could use your TI-NSpire to solve all the problems in this graph. Your TI-NSpire could certainly do all I showed you and more, but you certainly want to at least master the things I've shown you in these 3 videos, because it'll become necessary throughout the rest of the course. Okay. If you need any help with any calculator things, I'm happy to help.